4, where we're going to spend time rewriting equations and formulas. So we come across a lot of equations and formulas in math, of course. It's a large part of what we work with. And sometimes it's helpful to rewrite them in such a way that we get we isolate a different variable than maybe what's isolated. Helps us solve things, especially if we do a lot of repetitive calculations. So in this lesson, we're going to use properties of equality, rewrite literal equations, and we'll talk about what those are. And then we're going to use a formula to help us convert temperatures. All right, so literal equations are equations with 2 or more variables in them. That's it. Things like this: area equals length times width. Surface area equals pi r squared plus pi rl. Y equals 2x minus 7. I could list a whole lot of others, but you get the idea. And now sometimes it's helpful to isolate one of these other variables other than what's isolated. Like I said, especially if we have to do a lot of repetitive calculation. If I repeatedly need to know in this equation what's x, well then I may as well do everything else, get x by itself and say, okay, each time I plug in y, what x does it generate? Or in length times width in the area. If I know the area and I don't know the width, but I know the length, well then why don't I isolate the width and then just try what happens when I put in different areas or different lengths? What width do I get? That sort of thing, rather than constantly doing the same other calculations over and over and over again. Do one round to reset it and then just do the arithmetic that you need to do. All right, so let's take a look at some examples here. We're going to solve the equation for the variable indicated. Now, depending on your book, on the problems you're working on, this will be indicated in different ways. Sometimes it'll say it like this. It'll give you the equation and say you're going to solve for y. It might say isolate a particular variable in a formula. Rewrite a formula to isolate this variable. It might just mark it in red and say whatever one's in red or blue or green, whatever color, that's what you're solving for. Okay, so just be aware there's different ways you're going to see this. But this problem, negative 2x minus 3y equals 6, we're going to solve for y. That means isolate y. You are not going to get a one number answer with these problems. You're just going to get a new equivalent equation, okay? All right, so we want to get y by itself, which means we're going to add 2x to both sides. Opposite operations, that kind of stuff applies. Opposite operations, opposite order, keep the equation balanced. All that stuff still applies, okay? So that cancels there. Negative 3y equals, I usually put the variable term first, then the constant. You don't have to. And now I got to divide by negative 3. And I divide everything on the right side by negative 3. So I've got y. And then you could leave it like this. A lot of times, though, you're encouraged to split this up because this is really a common denominator. And you'd have 2/3 x, because the constants can come out in front, and then minus 2. I would accept 2x plus 6 over negative 3 as an acceptable answer. But when we get on later, in further chapters, when you divide both sides by negative 3, you're going to need to split it up because you're going to need to identify this number here as a slope and this number here is a y-intercept, so they need to be separated. So it's not bad getting that habit now. But this is your final answer. This is all the farther you can go because y is all by itself, okay? Now we're going to come over here. Here's a formula. S equals x squared plus 2x times L. L is actually slant height in this case. This is the formula for surface area of a cone. The area of a base, so a circle, times it's partially circumference, slant height, it's a whole thing. We got to get L alone. We got to get this slant height alone. So we're going to have to do a couple things. So we're going to work from what's farther away from L. So subtracting x squared from both sides. S minus x squared equals 2x times slant height times L. Now we're going to divide by 2x. Now here where we have a variable, I would not split it up anymore. I would just leave it like this and say the slant height is surface area minus x squared over 2x. Because the only other thing you would do is you'd have surface area over 2x minus x squared over 2x, and then technically things you don't know yet, the x squared and the x cancel, and so I would not do that yet. That's stuff that comes later on. Leave it like that. If it's just a number, then maybe split it up, especially if you can see something that would reduce in one of the terms. All right, one more. Interest equals principal times rate times time. Simple interest formula. We need to solve for the principal. All of this is multiplication, so we can divide by both of those things put together, rate and time right together. Divide both sides by RT. Principal is equal to the amount of interest divided by the rate times time. There you go. That's all you got to do for that one. All right, so temperature formulas. Those are something we use to help convert temperatures depending on where you are in the world. Here in the United States, we use Fahrenheit, but elsewhere in the world, they use Celsius. So it's good to know how to convert between the two. So if you ever travel or you're talking to somebody from somewhere else, you can kind of understand each other's temperatures a little bit better. So right now we have the formula for Fahrenheit based on Celsius right here. 9/5 times Celsius temperature plus 32 gives us our Fahrenheit temperature. We're going to take this equation, solve it for C, solve it for the Celsius. Then we're going to take our Celsius formula that equals, if we have the Fahrenheit, how do we get to Celsius? 5/9 times the quantity of the Fahrenheit temperature minus 32. We're going to solve for F. Theoretically, and hopefully in actuality, this formula here should solve, and our answer should be this. So Fahrenheit should turn into the Celsius equals, and our Celsius equals, when we get down here, F equals, should get us to the formula that we had up here to start with. But it's just a practice at manipulating things. That's why I'm doing both of them. All right, so here, let's start with this one. We get C alone. Well, what's farthest away from C? 32. Let's subtract 32 from both sides. F minus 32 equals 9/5 C. All right, well, I got to get rid of the 9/5, so it's a fraction. Easiest way to make that disappear, multiply by its reciprocal. Well, on this side, that just cancels out. Over here, both things need to be multiplied by 9/5, so I'm going to throw parentheses around it, or times 5/9, I'm sorry. I'm just going to write it right there. And we're going to say C equals 5/9 times F minus 32. Oh, look at that. Oh, there's that answer. Now let's see if we can go the other direction. Let's see if we can get to Fahrenheit equals something. Well, here, 5/9 is the thing we need to get rid of first. Multiply both sides by 9/5. So now we got 9/5 C equals F minus 32. How do we get 32 to move? So F is by itself. Yeah, 32. So now we have F equals 9/5 C plus 32. Right, that's what we had up here. So you can see these two formulas are obviously very interrelated to each other. And with just a couple of steps, we can get from one to the other. Okay? All right, so we're going to keep these formulas handy because, well, they're going to come in handy here on this last question. Which is the greater temperature, 400 degrees Fahrenheit or 200 degrees Celsius? Well, in order to make a fair comparison, just as we would with anything else with measurement, we have to have the same units. So we can solve this two ways. We can take our Fahrenheit, turn it to Celsius, or our Celsius to Fahrenheit. Now, depending on how you think, you can go either way. But I'm going to do it both ways. So depending on how you think, you're good to go either way. So which is greater? All right, well, 400 degrees Fahrenheit is equal to what degrees Celsius? Well, if I know Fahrenheit, then I'm going to want to plug it in here and say, what is Celsius? So Celsius is equal to 5/9 times 400 minus 32. And order of operation says I would subtract first and then multiply by 5/9. Well, what's 400 minus 32? Should be 368, right? Yep. So Celsius is equal to 5/9 times 368. And then on your calculators, you could just multiply 368 and then put in parentheses 5 divided by 9. And you get an answer of 204.4 repeating. 204.4 repeating. So that is greater than 200 degrees Celsius. So 400 degrees Fahrenheit is greater. Now, what if we said, all right, I want to do this the other way. I want to turn I've got 200 degrees Celsius, that's equal to how many degrees Fahrenheit? Because that's how you're thinking. I want to compare Fahrenheit to Fahrenheit. Okay. All right, so then we say Fahrenheit, F is equal to 9/5 times 200 plus 32. Now, what do? Multiply first. Well, that goes into your calculator, 9 divided by 5, times 200. You could probably also do some of this on your own. That's 360. 360 plus 32 should be 392, right? Right. So that means that's 392 degrees. That is less than 400 degrees Fahrenheit. So once again, 400 degrees Fahrenheit wins, which should happen anyway. All right, so now you should be able to rewrite literal equations for whatever variable is called for and convert between different temperature formulas. Thanks for watching.